Welcome back. As I said in the previous lecture, that I will be starting work, power, and energy. Now, this is very interesting. If you see, what is work here? What is work here? What is energy? And what is the power? Everything we have to see in detail. Now, of course, various people live in various ways. Now, in physics, work means result oriented. It is like corporate colleges. Whether the student knows or not, he is a muff or not, he is mediocre or not, he is good or bad, he should get a rank. So they say, the institute claims, yes, we got that rank. This is how it happens. So their rank is produced. That's all that is important. Physics, surprisingly, is also. Now I'll give you an example. For example, you put in a lot of hard work the previous night, and the following day you have an exam. You go to the exam. Suppose you could not write the exam properly, right? Now, you say, I have put in a lot of hard work, but somehow I could not write the exam. What is the result? You may fail in the exam. I'm giving you, but this is not a warranted comparison, but you should understand colloquially what do you mean by work. Say, for example, I will come to the physics part of it. Now you go and push this ball, let's say. Without even thinking for a while, you just go right and start pushing the ball. You know that you will not be able to do it. And you do for an hour, 2, 3, 4, and you say, sir, I have put in 4 hours of work. How much of work you put in? Now you say, I have put in 4 hours of work, I spent so much of energy. Now comes the problem. How I say that I have done the work. The other fellow says, you have not moved the ball even an inch. So you did not perform any work. Now look, he put in the efforts. He put in the efforts. He could not produce the result. Therefore, in physics, unless the result is produced, we do not say that work is performed. This is a very, very important point. I'll talk about work more because a lot of things we should know about work, not the one that is given in the book. I'll tell you what is given in the book. For example, you are asked to move a particular box. So you try to move them. Now, let me tell you. Suppose the surface is smooth, or on the surface you have spread all the oil, everything grease. So you are pushing the body. And even a little effort is enough to move the body. You need not have to do any work, I am saying. Because a small push is enough impulse, it will automatically go. Is this clear? They are automatic, isn't it? A small push, it will automatically go. The work is performed. But if there is friction, then you have to put in some efforts. I'm applying, say, friction, maximum friction, and limited friction is 100 newtons. I apply 50, 30, 80, 90, it will not go 100, yes. And then I will have to go beyond 100, maybe in that direction about say 150 newtons of force I am applying. 100 newtons is opposing. What is the effective net force acting on the body? 15 newtons. So because of this 15 newtons, how much the body has moved? Let me say the body has moved by 2 meters. 15 newtons, 2 meters. So, and suppose in another case, you are taking 100 newtons force and it is moving by 1 meter. So work, how much did you do? So it depends on the force that you apply, net force that you apply, or the total force that you apply, or what is work done by friction, everything you can say. When I say 100 newtons, 1 meter, and here 15 newtons, 2 meters, I say physics talks about the work to be the same. The work will be the same. This is very crucial. In the same direction, say for example, sigma F is 50 and this is 2 meters, the body has moved. Work done is say 100 Newton meter. In the other case, sigma F is 100 and this moves by 1 meter, here also 100 Newton meters. In both the cases, the work done is same. So, in the direction of the force, if the displacement is more, force is less, or displacement is less, force is more. So, it is directly proportional to the force in the direction of displacement and the displacement magnitude itself. If this work is directly more force, more work, less force, less work, but this force, more displacement, more work, less displacement, less work. So, work is nothing but a product of these two. It is an index, that is what we call as work. So, magnitude of force, magnitude of displacement, and this is along F. Along F. So, when you say along F, there is a problem now. Say, for example, I am giving you the physical concept here. I want you to be a little patient. Suppose I am applying a force like that. What is the component of force responsible for the displacement? Now, this is total force. What did I say here? Along the force. So, as far as this is concerned, I take mod F. Mod S, this is yes, along the force. If this is theta, this is theta. Therefore, this is S cos theta. As per this definition, this is the force. Or, in the direction of displacement, what is the force? Force is F cos theta and mod S. Remember, both are not the same. And you saw F is a vector, S is a vector, and you are getting mod of these two multiplied by cosine of the angle. So this is nothing but your dot product. Therefore, work is defined as F dot S. But remember, it's not as simple as this. If you take a small amount, so you may have to get the work by integration. That yes, if it is constant, you can take it like this, there is no problem. But this F dot ds is very crucial. So this is a function of theta, this is a function of F, this is a function of S. In other words, I want to move this body from here by 1 meter. By this I am applying 100 newtons. But how much of force is responsible for moving this body by 1 meter? All the 100 newtons is not responsible because a component is pushing it down and only a component is responsible. So the product of the displacement and the force responsible for it is what we call as the actual work done. Now, if in the direction of the component of force, if the displacement is there, then we call it as a positive work. Because I am pushing it going. Let me presume here is a case. I am applying F here and this is moving by S. What is work done by F? I call it as WF is equal to Fs because both are in the same direction. Now, the opposing force is Fk. Kinetic friction is present here. What is the work done by friction? What do you do? Fk. I am saying by friction. This is Fk, but displacement is in the opposite direction. So, I will take minus Fk or by definition, this is F dot S, this is Fk dot S. F dot S is how much? Fs cos 0. Fk dot S is Fk S cos 180 because these two are opposite. So this becomes minus Fks. So what is the work done by friction? Now I say it is negative. Now you get a doubt. What do you mean by work negative and work positive? Do you have any negative money? It all depends on how you view negative side. See, how much of property do you have? I say I've got minus 2 lakhs. Now, what do you mean by minus 2 lakhs? No, I want to be positive. I want to say, but I have a loan of 2 lakhs. But I don't want to say that I have a loan of 2 lakhs. Is a very nice way of talking about the same thing in different ways. So then he says negative money. Negative money or positive money means this. Work in a way, I'll tell you what is the positive. I told you, if the force is producing displacement, fine, you go ahead, force into displacement is work. That is excellent. But if I take there is a frictional law. Now I have to do work against the friction. Suppose what work is done against the friction. Against means negative, opposite. I will give positive answer there. What is the work done by friction? I will give negative. That's all the difference. You get my point? I repeat. I am applying 100 newtons. And the opposing force is 30 newtons. What is the work done by my force? If the displacement is 1 meter, I will say 100 into 1 is positive. So plus 100. And Newton meter is actually in physics it's called a joule after the famous scientist who performed several experiments in work equivalence of energy, etc. Heat and work equivalent, heat and energy equivalent. Many things he worked on that. So after his departure with this work is named after him, units. So the unit is joule, 100 joules. What is opposing force? Friction. What is work done by friction? Minus 30 joules. What is the net work done? Net work is total 70 joules. Or, if I take 100, this is 30. What is the net force here? 70. How much is the displacement? So 70 into 1 meter 70. That way also you can find out. Do you understand? No. Supposing if Fk is not there, it is 0. What is the work done by your force? Your work done is 0 because you need not have to put in any effort, it will automatically go on its own. So where should you do work? You will have to do work only if there is something to oppose. If nothing is opposing, there is no question of you doing any work there. This is a very important point. I hope you are able to follow. So work is a very typical concept. Work is a very typical concept. You should understand it in detail before I go to the actual mathematics involved. I'll talk of all the theory behind this till you understand the whole thing. Then only probably I can give you all that. Okay? Now, so what I'm saying in this way, negative, positive. Where do you come across positive work? I mean, say for example, if a coolie is taking a load and standing. What is the work done by coolie? Now, whenever you say work done, you have to indicate by which force or against which force, otherwise work done is meaningless. We will take net work done in which case. Here the net work done is 0 because there is no displacement. There will be no force, there also displacement is 0. I am trying to push the wall. I am trying to push the wall with force F, no movement, work done is 0. Yeah, I am telling you, now for example, I have a body, this is a smooth surface, and I try to apply a force. No matter what is your displacement, work is 0. Never try to multiply with this force and this displacement, say this is the work done. You need not have to do it, you just push it, it will go automatically on its own. Is this clear to you? These are all 0 work. 0 work is very important. Where else you get 0 work? Centripetal force work is always 0. Centripetal force work is always 0. Why? Displacement is tangential and CPF is perpendicular to the tangential direction. Therefore, theta 90, therefore work done is 0. I'll come to the various cases of work done, etc. Okay? So, I'm just giving you some few examples. Now, a person is climbing the stairs, right? What is the work done by this person? Against gravity. So, against gravity means you see how far he has gone up. How far has he gone up? In the direction of force. What is his displacement? No matter how he goes. So, mg h cos 180 because displacement upwards, force downwards. So, this is you understand this point, but this is very, very crucial. Okay? Yeah. Now the various cases, not like this. For example, there is no staircase. There is no staircase. Now here the body is falling here. It has come down to this point. Suppose, I'm just saying. Let us say it has just come here and stopped. Just before reaching its velocity is 0 and initial velocity is 0. This is it is all rough surface. How many forces have done work here? See, work done by normal force is 0 unless along the normal force you get the displacement. Okay? So in this case, along that there is wherever I take, like this. If this is the displacement, now I take this as theta. Now, if I take this as say yes, this is delta x, that is delta y, okay? And this is delta yes. So, what is the displacement in this direction? So you say delta x is delta s cos theta. You get the point, and what is the displacement in this direction? Delta y sin theta. Now, frictional force is like this. If it is coming, this is the frictional force. You get the point? And if frictional, what is the component of friction? How do you write your frictional force? Fk, dfk, whatever is mu n. What is n? If I say dfk is a small, say dn. What is dn? Now, if this is theta, mass, this is mg, okay? This is mg, and this is n. Therefore, what is this component? This is net, this is theta, this is mg cos theta, and this is mg sin theta. Okay? So, mu dn, how do you write? dfk is equal to mu dn ds cos theta. Did you understand? Not mu ds, mu g. Isn't it? Mu mg cos theta. Because mu n, dn is mg cos theta, so mu mg cos theta. What is work done by friction? What do you do? Friction is like this, displacement is like this. It is a negative, obviously. Okay? If I multiply with the ds, mu mg cos theta ds. This is dw. But what is ds cos theta? dx. Mu mg dx. This is work done by friction. So you integrate it. What do you get? Mu mg dx dx. What are the limits of x? 0 to s. So the answer is the work done by friction in this case is minus mu mg. Is very interesting, remember. Minus mu. What is the work done by gravity? See, mg down, this is down, therefore mgh. And the body stops here. If the work done by these two is equal, then I will say the total work done is 0. You get the point? Because if I take that here and here, the body has come to a stop. The total work done is 0 in this case. If that is the case, What do you write? MMGG H is equal to mu s. If that work done is zero, what is mu? You may give your answer. This is a concept I am just trying to deal with. Okay? You can probably work on positive, negative cases. Don't say work done by friction is always positive. You see, work done by friction. Fk, work done by friction is negative here because S is in this direction. Now look, here F2K, F1K, work done by F2K is positive. Why? F2K displacement are in the same direction. You have a negative work by friction, you have positive work by friction, and wherever friction acts as CPF, only friction acts as CPF, work done by friction is zero. Now remember, work done by gravity can be zero, positive, negative, work done by friction can be zero, positive, negative, all depends on the situations. Right? Now, having understood this to some extent, if not fully, now we go little deep into it. First of all, I said, when is the necessity for you to do work? The body moves on its own, you need not have to do anything. Okay? So, if it is not able to move, even when you put in effort, then you have to really do work to move it. So, always you are supposed to do work against some opposing thing. Say, for example, here is a chamber, all gas. I have confined the gas to half of it. Okay? Now I have punctured this. Nothing is present in the other half. It's called vacuum chamber. When you puncture this diaphragm, gas occupies the entire. What is the work done by the gas? Supposing it's a general way. You know the ideas, but the work done is zero. Because no pressure is opposing. No pressure is opposing. After all, if you say FDS is your work done, F is pressure into area and area is dV. So pressure multiplied by change in volume is the work done. What do you mean by this pressure? Against which? Here P is zero, therefore work done is zero. So when there is nothing to oppose, your work done is zero. You have to be very, very careful in giving this answer. Zero water, there are many cases. I will talk about that, but not before I discuss a very important concept. Conservative and non-conservative forces. This is very important. I am going to deal with this, but remember, what is work? When people ask, work is not a thing that you store within you. See, nobody can ask you a question how much of work you have stored. Yeah, he can say how much of energy you have stored. That is accepted. How much of work do you have? Meaningless question. You understand my point here? Yeah, how much of? Now similarly, heat also, it's a beautiful concept. Work and heat are absolutely similar. Both or transient phenomenon, both. It may occur in pockets. It will take place, next time it may not be there. May be present, may not be present. If you take the concept of energy, energy is always present. Like a temperature, temperature is always present. But heat need not be present. Work need not be present. It is a transient phenomenon, discontinuous. Both are discontinuous, discrete. Discrete. It is energy in transit. I am moving the body. As long as the body is in motion, then only work is being performed. The moment that body comes to rest, that's out. So only during that, so it is called energy in transit. In fact, work means transfer of energy mechanically from one system to another. One system to another system. The transference of energy is what we call as work. The transference of thermal energy is called heat. Heat and work, there is no difference, my dear friends. You must understand, when I talk about heat, I will give you an explanation for that. But as of now, I will not go deep into it at this stage, other than saying that both are energies in transit, both are similar in every respect, and this is an inexact differential. Delta W and similarly delta Q. Now, inexact differential means if I take integral over a closed surface, if that is 0, then I call this as exact differential. If it is non-zero, it is inexact differential. Heat is definitely inexact. Work is inexact provided it is by non-conservative forces. And right, if it is conservative forces, but then it is dW. This is the reason why I want to discuss this in great detail. Okay? Now, I gave you enough introduction. You now know. Okay. What do you mean by conservative force and the non-conservative force? What do you mean by conservative and non-conservative force? Now you know one thing, right, from your say 6th, 7th, 8th standard. You have been hearing of conservation of energy. Conservation of energy. Of course, that's a very vague way of talking about conservation of energy. Energy can neither be created nor destroyed, etc., but can be converted from one form to the other. This is how we have been giving the definition of, the enunciation of energy conservation. But if you say, I take a closed system, remember, when I talk of systems, there are 3 systems: open, closed, isolated. Open means energy